Okay, true or false? If the first two terms of an arithmetic sequence are positive, then so is the third. Explain. You guys thinking about it? Here, I'm going to give you an answer. What if I have a sequence of, say, 5, 2, -1? So what's happening here? I'm adding -3 each time, so you can see this will continue on. First two terms are positive, but all the rest of the terms will be negative. So basically it really depends on where you're starting and whether your common difference is positive or negative. Okie doke? Okay, let's get into our lesson. Today we're covering 9.5 series. Our objectives are to write sums of sequences using summation notation, to find sums of arithmetic and geometric sequences, to determine if an infinite series converges, to find sums of convergence of geometric series, to write repeating decimals as fractions, and why infinite series are at the heart of integral calculus. Language objective. I can explain how to find the sum of an infinite converging series. Okay, series is the sum of a sequence. So if the sequence is 1, 1, 2, 3, 5, 8, 13, you might recognize that as the Fibonacci sequence. The series is 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus 13. So we write series using sigma notation. Sigma is the capital letter in the Greek alphabet. And sigma basically means sum. You can read this. My writing hasn't gotten any better. So here we have the sum of our rule here, the sum of a sub k. This is our rule for k equals 1, which is the first term, to k equals n, which is the last term. Now you don't always have to start at 1, you can start at other numbers as well, but these are usually the counting numbers, 1 to some number. So the way we read this is, see if I can write this down here, the sum of a sub k from k equals 1 to k equals n. So the sum of a sub k from k equals 1 to k equals n. I'm sorry it looks so bad. So let's find the sums. So to find the sums, really all we have to do is evaluate at each number k. So starting at the top one up here, if I stick in a 1, I have 1 plus 2, that's our first term, plus 1 plus 2 times 2 is 4, plus 1 plus 2 times 3 is 6, plus 1 plus 2 times 4 is 8. So what I get is 3 plus 5 plus 7 plus 9. Adding 3 and 7 I get 10, and 14 more, it should be 24. Okay? Down here I have a different type of sequence. You might recognize it as geometric. It's a series. So the sum of 8 times 1/2 to the kth power from k equals 0 to 4. So let's add that one. So when k equals 0, I have 1/2 to the 0, which is 1. And you know what I'm going to do out here just to make this easier? I'm going to take my 8 and move it out here, because then I don't have to multiply by 8 each time. I can just do it once. So 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. 1/2 cubed is 1/8. And 1/2 to the 4th is 1/16. So if I add all these together, I'm going to get 8 times 1 1/2, 1 3/4, which is 6/8, 7/8, which is 14/16, 1 15/16. Dang, this is really hard to control. It's a 6 down there. So that's going to be 8 plus 8 divided by 16 is 2. So 15 halves, which is going to be at 7.5, plus 8 is going to be 15.5. Okie doke. So, you guys, let's see. Let's express this one in sigma notation. So, let's find out what's happening with our series up here. Up there. You notice here I'm adding 6. 6 plus 6 is 22. There's a boo-boo there. Okay, this one on your sheets has a typo in it, so make sure you correct it. So you should have 4 plus 10 plus 16 plus 22 plus 28 plus 34 plus 40. So if you look at here, what we're doing every time is adding 6. So it's an arithmetic sequence. So let's find a rule for it. So a sub n equals a1 plus n minus 1 times d, which equals 4 plus n minus 1 times 6, which equals 4 plus 6n minus 6, which equals 6n minus 2. Okay? So that's our rule. So what we're going to do is write that in sigma notation over here. The sum of k equals 1. How many terms are there? 1, 2, 3, 4, 5, 6, 7. K equals 1 to 7 of 6n minus 2. There you go. So to write something in sigma notation, find a rule for it, count the number of terms, put it all together. You guys try the second one, okay? I'm going to do it up here while you do it at your desks, so just give it a good go. I did make a boo-boo up here. You should always put a k in here, not an n. So this should actually be 6k minus 1. Okay, so your rule for the second one, the sum from k equals 1 to n. When it's an infinite series, we just put an n at the top. The rule is k. This would be the kth term. K equals 1, 2, 3, 4. On the bottom we have odd numbers. Normally we express odd numbers as 2k minus 1. So you kind of just look to see what's going on with your terms, and you write a rule. So you guys try this one as well. I will do it here along with you. If you notice here, the one thing we don't know is what term number this is. So in order to find the term number, k, you're going to have to use your equation here and solve for it. So I'm going to get 53 equals negative 7 plus n minus 1 times 6 equals negative 7 plus 6n minus 6. And I guess I could have just stuck it in that equation as well. 53. We had 13 to each side. I get 66. 6n n equals 11. So yeah, you could have just stuck your 53 right here. So you should get k equals 1 to 11 of 6k. 6k minus 13 and 4k equals 1 through 11. Okay? Okay, so if we have an arithmetic series, we might have to add this by hand, which could take a lot of time. But one thing that you might think about doing here is if I add the first term to the last term, and then the second term to the second to the last term, and so on, you're going to notice here that if I add each of these, the sum is going to be the same. So you can see that if I take the first term, which is a1, and I add it to the last term, which is a sub n, I'm going to do that, well, I have 8 terms here, and I did that 4 times, so n over 2 times. So I have n times a sub 1 times a sub n over 2, and that's going to be our formula to add arithmetic series. Okay, so our arithmetic series formula is going to be s sub n equals n times a1 plus a sub n all over 2. So if you come down here, we're going to try to find the sum here. So I know my a1, I know a sub n, what I'm missing is n. So the first thing I need to do is find what n is, and I'm just going to use my formula for arithmetic series to do that. Okay, so a sub n, 174, equals negative 12 plus n minus 1 times 6. 174 equals negative 18 plus 6. Add 18 to each side. 192 equals 6n, which means that n equals 32. So now that I know n, I just plug it in the formula. 32 times negative 12 plus 174, all divided by 2. It's going to be 16 times 162. Pop that into my calculator really quickly. And I get 2592. So hopefully that checks and you guys get the same thing. Nice. Well, I did the second one here. If you can still see the top one, the sum of 3 plus 5 plus 7 plus 9 plus 11, why don't you guys go ahead and try that one. See what you get. I'll do it on the side over here. Sorry, this is such a mess here. One, two, three, four, five. Okay, so the sum of a finite geometric sequence has its own formula as well, and let's write that down. It's a1 times 1 minus r to the n all over 1 minus r. Okay, so you can see for this formula, you need n, you need a sub 1, and you need r. Okay? So if I want to find the sum of the first 8 terms of the geometric series, I can just plug in. This one I don't have to find the 8th term. So s sub 8 is going to equal 14 times 1 minus, looks like I'm multiplying times negative 5 here. So 1 minus negative 5 to the 8th all over 1 minus 5. It's going to be 14 times negative 5 to the 8th. actually, I'm just going to do the 1 minus negative 5 to the 8th, which is going to end up being 1 minus 5 to the 8th. And I got negative 390,624. So, negative 390,624 all over negative 4. Put that back into my calculator. And I got 1,367,184. Okay. Okay, why don't you guys try this next one here. I'm going to do it on the board is when you do it at your desk. Okay? I got 255 over 16. Hopefully you got something similar. Okay? So how do you add a series that is infinite? Technically we can't do that, but the sum, in quotes, of an infinite series is not a true sum. But the sum of a series may approach a finite limit s. So this looks like all this fancy gobbledygook, but you can write it down. Sum of a series for the rule a sub k, for k equals 1 to infinity, equals the limit as n approaches infinity of k equals 1 to n of a sub k, which equals s. So what this says is the series converges at s, and if the sum doesn't exist, then the series diverges. So, which of the following series appear to converge? Well, this one is getting smaller and smaller and smaller, and so if the term number gets big enough, we're going to be adding virtually any or nothing here. So this one, we would say, converges. Okay? What about this one? Well, this one, it appears that our numbers are getting bigger, so they're just going to continue to get bigger, and the series is going to blow up. So this one converges, A converges, this one's going to blow up, diverges. The last one, we go between 1 and negative 1. I think we talked about this one. Negative 1, it keeps going back and forth, it diverges as well. Okay? So find the first 6 partial sums of the following infinite series. So you guys do these, tell me whether they converge or not. Okay, I got convergent and divergent. Hopefully you got the same thing. Okay, this geometric series here, a times r to the k minus 1 for k equals 1 to infinity. Look at the series. What is the sum? Well, this one, our sum is going to be 1 1/2, 1 3/4, 1 7/8. Every time we're adding a smaller number, so we're getting pretty close to 2 there. What happens when n becomes larger? Well, we start to approach 2. So the geometric series is going to converge if and only if r is less than 1. Actually, 0 is less than r, which is less than 1. We don't want it to be like -10 or something. So the formula for an infinite series is going to be this. S is going to equal a1 over, let's see, 1 times 1 minus r to the n, all over 1 minus r. Well, if r is less than 1, this approaches 0, and so we get a much simpler formula, which is a1 over 1 minus r. Remember, r has to be less than 1. Actually, 0 is less than r. Well, absolute value of r is less than 1. That makes sense. When the absolute value is greater or equal to 1, the series will have no limit. So let's find the sum of 60 plus 24 plus 9.6 plus infinite series. So first, let's check if r is less than 1. So to find r, I need to take the first term. I know the first term times r is going to equal the second term. So basically, r is going to equal 24 over 60, which is going to equal 4/10 or 2/5, okay? So r equals 2/5. Okay, well, r is less than 1, so our formula is going to work. S equals a1 over 1 minus r, which is going to be 60 over 1 minus 2/5, which is going to equal 60 over 3/5, which is going to equal 60 times 5/3. 20 times 5 equals 100. Okay? So, this would be the limit of our infinite series. Approaches 100 and never quite reaches it. Okay? So you guys try this one. I'll do it up here while you work at your desks. Okay, we can use the infinite series formula to change decimals to fractions. One cool little thing. So in order to do this, what we need to do is write a repeating decimal as an infinite series. So 0.24 equals 0.24, 24, 24, and so on, which equals 0.24 plus, now it repeats after 2 decimal places, it repeats after 2 more decimal places, and so on. So this, we can recognize this as an infinite series. So I know that a1 equals 0.24. r, since we moved everything over 2 decimal places, will be 0.01. And now I can solve. So the sum is going to equal 0.24 over 1 minus 0.01, which is 0.24 over 0.99 is going to equal 8 over 33. So there we go. We wrote it as a decimal. Okay? You guys, try these. I'll be working on them up here as you work at your desks. Okay, there we go. So a rubber ball is dropped to the floor from a height of 27 feet. If the ball rises at each rebound to a height 2/3 of its previous height, find the total distance the ball travels before coming to rest. Okay, so this is 27 here. So I start at 27, I bounce to the ground, I come up 2/3 as high, I bounce to the ground 2/3 as high, and so on. So you can see here that your R is going to be 2/3. Okay? So what I have is 27 plus 2/3 times 27 plus 2/3 squared times 27, and so on. So here you can see my R is 2/3. We figured that out. And we're going to treat this as my first term instead of doing an n minus 1, which you could do. So what I'm going to do is just be adding 27 to my series. Okay? And what I could do really is just pull out that 27. And I'm going to get 1 plus 2/3 plus 2/3 squared, and so on. Okay? So A1 equals 1, R equals 2/3. So S equals A1 over 1 minus R equals 1 over 1 minus 2/3, which equals 1 over 1/3, which equals 3. Okay, don't forget though, this 3 is getting multiplied by my 27 because we started from 27 feet. So I have 27 times 3, the answer would be 81 feet. The ball travels a total of 81 feet. Sound good? Okay, there's your language objective. Try to explain how to find the sum of an infinite converging series. For an infinite geometric series, if the absolute value of R is less than 1, the series converges. This means R sub n will approach a limit S. So the sum formula becomes S equals A1 over 1 minus R. Okay? There's your homework. I will see you guys on Tuesday. You have a great weekend.